Okay, so now we want to factorize. Let's look at the first one. Okay, so when you think about like 6, you can write 6 as 1 multiplied by 6. You can write it as 2 times 3. When 6 is written in these forms, we say we have factorized 6, which is really writing it as product of its factors. So that's what we're saying when we say factorize. It's another way of saying write them as a product of their factors. All right, so let's do the same thing here. All right, with these expressions. So we have 8 x to the third y plus 4 x to the fifth y squared. I want to write them as product of their factors. In terms of 8, we can write 8 as 2 times 2 times 2 times 2. I'm just using 2 for now, right? 2 times 2 is 4. Okay, I think I've written too many. Right? So that's going to be 2 times 2 times 2 times, now the x cubed, I can write that as x times x times x. And the y, put it back. Plus the 4, I can write it as 2 times 2. The x to the fifth, I can write it as x times x times x times x times x. And the y squared, I can write it as y times y. Now, I'm doing it this way because it's perhaps the easiest way for you to understand it for now. But if you can do it just quickly, swiftly, no problem. Find the easiest method. All right, so this 2 times 2 times 2, that's 8. X times x times x, that's x cubed times y, of course. Then 2 times 2 is 4. X to the fifth can be expanded as x times x times x times x times x. Y the second can be written as y times y. Got that? Is that clear? Okay, great. Now what we're going to do, we're going to pick out the common factors. Now these are all factors. Once you're multiplying terms or numbers or letters, they're all factors when you put them together, okay? So for instance, again, if you have 6 and put it as 2 times 3, 2 and 3. Right, let's use the times there. Here's a dot, a raised dot, or a multiplication sign. Now, 2 times 3. 2 is a factor of 6, so is 3. So the same thing we're doing here. All these that we're multiplying are factors of the first term. All these that we're multiplying here, factors of the first term. All that we're multiplying here, factors of the second term. And so, let's pull out the common factors. I have 2 times 2 here, and I have 2 times 2 here. So if I pull that out, well, 2 times 2 is really 4, right? This is actually 4. And we can see why, because 4 is a factor of 8, and 4 is a factor of itself. So we're pulling out the 2 times 2, which is 4. Let's pull it out. Let's see if we can get any common factors in terms of the x's. We have 3 x's multiplying here. Can we get 3 x's over here? Yes. So we'll pull all of that out. Now, x times x times x, we can contract that, just like we contracted the 2 times 2 as 4. The x times x times x, we can contract that as x cubed. So x cubed is what's common. So we can put it next to the 4. That's also common. Let's look at y. We have 1y here, and we can get 1y over here. So that's common as well. Y to the first power is common. And that's it. Then we're going to put insert, open bracket. Now, what's remaining on the left-hand side of this plus sign here? What's remaining on the left, on the left-hand side? Well, only this 2 here. We did not account for the, well, we did not, I shouldn't say we didn't account for the 2, but we did not this wasn't a common factor, that 2 here. On the right-hand side, what's left out? The x times x here and y. So we're going to basically put those in the bracket. And the plus sign, we want to put the plus sign in the middle to separate the terms. And on the left hand side, we'll have the 2. That's the only thing that's remaining on the left hand side. On the right hand side, we have x times x. There, right? X times x, we can written as what? X squared. So we're going to put that in the bracket. And we have a y here. Let's put that y there. And that's it factorized. All right. So some person are able to just look at the, some people are able to just look at the 2 terms given and able to just find the common factor, as in 4x cubed y, and then put the what's remaining, the 2 plus xy squared y inside easily. All right, we could go through that, but that's take a little bit of time. So let's move on to the next one. Okay, so that takes us here. Now, what we have here should be able to identify. You should know what square numbers are, right? 1 times 1 is 1. 2 times 2 is 4. 3 3 is 9. 4 4 is 16. 5 5 is 25. 6 6 is 36. 7 7 is 49. 8 8 is 64. 9 9 is 81. 10 10 is 100. 11 11 121. Next 144. 169. 196. And so forth. Right? 15 15 is 225. 16 16. 256. And continue going on. But the idea here though is these are all square numbers. Now, as long as you see the numbers themselves are square numbers on the right of the minus sign, and on the left of the minus sign is also a square number, and the variable given is raised to the second power, all right, then we most likely can factorize as the difference of two square numbers. Let me show you how. So what you're going to do in this case, you're going to rewrite the first term as a number being squared. Rewrite the second number as a number being squared. Let's focus on the second number. What number being squared gives us 25? 5. 5 squared is 25. The second one, what number being squared gives us 4y squared? Remember, the entire number has to be inside. Our term has to be in the bracket. So the y will be in the bracket for sure to give you y squared. And what squared give you 4? 2. So 2y, 2b squared is 4y squared. What I'm saying here is that 2y multiplied by 2y give us 4y squared. I'm sure you can see y. 2 times 2 and y times y. Okay, now when it's written like this, you're going to get the product of a binomial multiplied by what we call its conjugate. We're going to have plus in one bracket, minus in the other. So in the first bracket, you're going to have the 2y. And the second bracket, you're going to also have that same 2y. In the first bracket, after the plus sign, you're going to have the 5. And in the second bracket, you're going to also have the 5. So you should basically, it's almost identical. It's just that in one you have a plus, in the other you have a minus. Okay. Now, if you think that you understand it, but you're just not sure if you get it, I could just quickly show you another one, right? And that should probably do it. Let's use 64, for instance. Should I use that one? Let's use that one, yes. Let's use 9x squared. Okay, 9x squared minus 64. All right, so these numbers are jumping all over. One moment. All right, so let's look at these examples. If you notice, 9 is a square number, 3 3s. In other words, 3 squared is 9y squared minus 64 can be written as 8 squared. Let's check this other one over here. This is going to be 5 squared. The m squared is already there as a square. And 81 is 9 squared. Now what we can do with this, we can basically write the two pair brackets. In the first we have 3y, and then it would be plus 8. And the other one, you're going to have 3y minus 8. So basically, we're going to ignore the squares and choose these guys. So in one bracket, I have a plus. In the other, we have a minus. Then put the 3y and the 8 in both. So the same thing is going to happen here. We're going to have two pairs of brackets. In one, you're going to have plus, the other minus. What are we going to put here? 5m. That's correct. We're going to have here the same 5m. We're going to have here now 9. We're going to have here the same 9 as well. It's basically almost identical, except in one you have a plus, a minus. We call this a binomial, right? Times its conjugate. This is conjugate, the conjugate of the original binomial. They're both binomials, mind you, but they're conjugates of each other. So if I give you the last one, 121 x squared minus 25. How would you do that one? Well, you know that you're going to get this, right? You're going to get what? A binomial. What sign should go in the first one? plus. In the second one, minus. Here's a question though. If I put a minus in the first one and a plus in the other one, would it be incorrect? No. Because when you're multiplying two quantities, the order doesn't matter. So when you put this one first and then this one second, or swap, or the other way around, doesn't matter. Okay. So 121 is a square number because 11 squared is 121. So we're going to have 11 here and 11 here. What square give us 25? 5. So we're going to have a 5 here and a 5 here. But I forgot something, the x squared. So we're going to have our x here and our x here. That's important. In other words, 121 x squared can be written as 11 squared x squared, and we just choose this portion now to go here as well as over here. And the 25 can be written as 5 squared. So we choose this portion to go here as well as over here. And that's that. Okay, so now that you've gathered how to do that one, let's go on to 3. So in this one, we're going to basically select the common factors, kind of similar to how we would have done number 1. So we're going to factor in pairs. We're going to look at the first part here, right? How are we going to do that? What's common? Well, we can do the same thing like how we did the first one. Let's see how that makes sense. So we're going to expand the 2p squared as 2 times p times x plus the 5 times p times y. I think I need some space. And then we're going to have the minus and then 2 times r times x minus 5 times r times y. So we have this set over here and this set over here. Let's identify what's common in both sets. So, well, in the first pair. So we have p, that's common here, as well as here. Anything else common? No. So we're going to pull out the p, and then open bracket, and what's remaining from that? We're just focusing on the first, this part over here. What's common? P, pull it out. And then we're going to have 2x and 5y. So let's write that. So in bracket, we're going to have 2x plus 5y. Okay. And then we're going to check to do the same thing to the other side. Let's see what's common. We have an r here and an r here. Anything else? No. So let's do the same thing. So we're going to pull out that r that's common. All right. And then we're going to have open bracket. Now, mind you, whatever we have over here, we want to have it over here as well, which is 2x plus 5y. So we want to have that there. All right. But there's a but. Notice that we want to get back negative 2rx. And r times 2x would not give you negative 2r. So you need a minus sign here. So you're either going to have a minus sign or a plus sign right here. And it should be a minus sign. All right. So when you multiply the, one second. Yeah, when you multiply the negative r by 2x, you're going to get negative 2rx. Negative r by, using distributive property, that is. Negative r times 5y will be negative 5 ry. You always put the number first. Now the next step after this is to complete the factorization. To complete the factorization, we're going to basically look at what we have in brackets. All right, we should end up with 2 pairs of brackets, just like we did with this guy over here. 2 pairs of brackets. But we're not going to have a binomial and its conjugate. We're going to have a binomial, but not with its conjugate necessarily. In brackets, if you notice what we have what? We have 2x plus 5y and 2x plus 5y. Well, since it's repeated, we're going to put it in just one bracket. The 2x plus 5y. And what's outside of the bracket? What's outside of the bracket? Let's see what's outside of the bracket. It's going to be p and minus r. So we're going to write that down as p minus r, and that's it. That's just it. Okay, so do you need one more practice with this? Let's see. All right, so let's look at this one. Let's see what's common in the, so we're going to group them off in pairs. So let's work on this one first. And we're going to see what's common, okay? Very easy stuff. So what's common in terms of factors? Because 7AP, the 7 is a factor, A is a factor, and P is a factor. Why? Because 7AP means 7 times A times P plus 9 times A times T. So what's common? The A is common as a factor. So we're going to pull out this A, right? Let's pull out that A. What's remaining? 7P plus 9T. Okay, and then if you notice, we have a minus and a minus, so we can consider the minus is common into both. And let's look at what's common. The B is here. The B here is common as well. So we can pull out that B. What's remaining in bracket? The 7P. Now, here you have to be very careful. Here's where I need to explain to you that you have to make sure that whatever you have, let me just put it over again. Whatever you have in bracket here must be identical to what you have over here in bracket as well. Okay, so you want to ensure, and I'm going to show you why it works. So whatever you have over here, repeat it over here. So it should be a plus 9T. Let's see how it works. So negative B times 7P, the negative times positive give you a negative, and B times 7P is 7BP, which is exactly what we have on top here, right? Which is going to be negative B times 7P is negative 7BP. And the same thing, use distributive property again, is that the negative B times the negative 9 should give us what we have on top here, right? So let's see, negative B times 9T. Negative times positive is negative, and B times 9T is 9BT, what we have up here. So hopefully that was clear. The next step, once you have factorized in the sense of what is in bracket there is the same as what's in bracket there, right? And you have your term here with the sign in terms of negative and B. Then what you need to do next is to, let's take that off, is to have the two pairs of brackets. What's in the bracket that's been the same, you put it in one bracket. And the terms outside, you put them together collectively in one bracket, the A minus B. All right, let's do the same thing to this guy on top here, over here. So we're going to factorize the two sets differently, or separately, I should say. What's common is A. We have A here as a factor and A here as a factor. So we're going to factor it out. What's remaining is 4x plus 5y. We have negative here and here. So we're going to factor out the negative. What else is common? We have a B here as a factor and a B here as well. So we want to factor out the B. And in bracket, because we have no more factors that are common, right? So in bracket, we're going to have the same thing that's here. I'll put it over here. So that's 4x plus 5y. And it will always work that way so that you can actually factorize further. Otherwise, you won't be able to factorize further. So it should be always set up that way for you. Okay, and what we have in brackets that are the same is 4x plus 5y, 4x plus 5y. And remember again, you can always double check to make sure that the last, if you multiply the negative b by 4x, you get negative 4bx. Negative b times 5y, you get negative 5by, which are the terms on top that we have. The same thing with the a times 4x, you get the term here, 4ax. And a times 5y, you're going to get the same term we have here, which is 5ay. Now, you're going to have two pairs of brackets. Tell me what goes inside the first bracket. That's correct. What we have in the brackets on top that are the same, the 4x plus 5y. What goes in the second bracket? That's correct. What's outside? Collectively a minus b. That's it. Now let's look at the last one in terms of factorization. X squared plus 8x plus 7. Now what you do here, you basically write the two pairs of brackets right away. Okay, and since the first term, now this one is where you have the first term being a square term, the second one being a, well, let's say a linear term, but there's the power on x is really just a 1. So the first term has a 2, the second term has a 1 on it, which we don't usually show, right? We don't usually write that. And the second term and the third term is just a number, right? So we call that a quadratic trinomial. Trinomial means 3 terms. A 3-term expression, basically. Quadratic because the highest power is a square. So when factorizing, so what we can do is look at the first term, x squared. And one way to get that is multiplying x in the first bracket by an x in the second bracket. All right, and then I'm going to have to work this out on another sheet, so just one moment. Okay, so here we are. So we're going to have the two pairs of brackets as mentioned before. We're going to have x here and x here because x times x give us the first term, x squared. So that's the first times the first, give us x squared. Now to get 7, 7 is a prime number, right? So what times what give us 7? 1 times 7 give us 7. Right, now let's see how that works. When you multiply the inner terms, 1 times x, you get 1x. When you multiply the outer terms, 1 times 7, you get 7x. Should you add these, right? Positive 1x and positive 7x will give us positive 8x. All right, this will always be, that should be the same as the middle term. Right, so that should be the same as the middle term. That's what we have in here, this middle term, 8x. All right, so that being the case, that means this should be positive and this should be positive. Why so? Well, let's write it out in a cleaner way. X plus 1 times x plus 7. If you were to try it, check it back. X times x is x squared. X times 7 is 7x. Then 1 times x is 1x. And 1 times 7 is 7. When you're simplifying that, the middle terms are like terms. 7x plus 1x is 8x. The last term is 7. So it really works. So this is our solution factorized. X plus 1 and then x plus 7. Let me give you another one just for practice. All right, so for this one, again, if you look at it, the first term is just x squared. The last term is 5. All right, so we know that x times x gives us x squared. And to get 5, we need to multiply. Only 1 times 5 gives us 5, so we can just put 1 here and 5 here. Put a 5 in the first, it's okay. So you could actually have 5 here and the 1 there. Doesn't matter in the end. But the key thing is realizing you're going to have positive here and positive there, because all the terms are positive anyways. So you cannot have negative. Once all the terms are positive, the factors should all be positives as well. And that's the answer. Well, let's check it though, all right? X times x give us x squared. 1 times 5 give us positive 5, which are the first term and second term. To get the middle term, now you need to multiply these and add them. So 1 times x is 1x, and x times 5 is 5x. They must all be positive. So when you add them, you're going to get 6x, because these are like terms. And 6x is what we have in the middle, right? So our answer is x plus 1 as a factor times x plus 5 as another factor. Okay, if I give you one last one, x squared plus 8x plus 7. Did we do this one already? I think so. Let's try another one. X squared plus 4x plus 3. What will be the solution? So x goes here, x goes there. What about the other terms? 1 goes here, 3 goes here, because 1 times 3 is 3. And plus is correct. Because x times x is x squared, first term. 1 times 3 is 3, second term. To get the middle term, we do the inner. That's 1x. the outer terms. X times 3 is 3x. We add them, we get 4x, the middle term right here. So that's correct, as being correctly factorized. So the answer will be x plus 1 in one bracket and x plus 3 in another. And so that would be it based on that.